Okay, now that we've gone through how to find the standard error when we're working with a difference of two means, let's work with a confidence interval. So Tribellis is a food supplement that some athletes use to enhance performance. A study on the effects of this supplement randomly assigns 20 athletes to take the supplement for a 20-day period and compared various characteristics to 12 similar athletes who were not given Tribellis. On the AAMP, anaerobic lactic muscle power measurement, the mean for the Tribellis group was 1305.6 with a standard deviation of 177. The mean for the control group was 1255.9 with a standard deviation of 66.8. Find and interpret a 90% confidence interval for the difference in mean AAMP between athletes taking Tribellis and those not taking it. The conditions are met for using a t-distribution. Are we 90% sure the Tribellis has an effect? Well, we want the difference between mean for Tribellis and mean for the control, where U sub t equals the mean AAMP measurement for athletes who took Tribellis for 20 days and mu sub c equals mean AAMP measurement for athletes who did not take Tribellis. So for confidence interval, remember it's statistic, plus or minus. This is working with mean, so it's t splat times standard error. T splat is the inf t 0.9 plus 1 minus 0.9 over 2. And we have a degrees of freedom of 11 because remember when you have two sets of data or you're comparing two sets of data, the degrees of freedom is one less than the smallest data value. So then we have x bar sub t minus x bar sub c plus or minus t splat times the square root of s sub t squared over n sub t plus s sub c squared over n sub c. Now when we do this inverse t, let's see what we come up with. So second vars, inverse t, 0.9 plus 1 minus 0.9 divided by 2, 11 degrees of freedom. And we come up with 1.796 as t splat. So we have 1305.6, which is the mean for those who took tribellus minus 1255.9. The mean for the control group, plus or minus 1.796 times the square root of 177.3 squared, which is the standard deviation for those who took the medication, over 20, which is the sample size, or the number who took the medication, plus 66.8 squared, the standard deviation of those in the control group, divided by 12, because there were 12 in the control group. So this gives us 49.7 plus or minus 1.796 times, if we work this out, let's do that. So we have 177.3 squared divided by 20 plus 66.8 squared divided by 12. Then we need the square root of that number, which gives us 44.086. So 49.7 plus or minus. So we have 1.796 times 44.086, which gives us 79.178. So 49.7 minus 79.178 gives us a negative 29.478. 2 and 49.7 plus 79.178 is 128.878. So for our interpretation of the confidence interval, we are 90% confident that the mean AAMP measurement for athletes taking tribulus is between 29.478 points lower and 128.878 points higher. Than the mean measurement for athletes not taking tribulus. Now the last question, are we 90% sure the tribulus has an effect? Well, because 0 is within this interval, we aren't sure whether it actually has an effect or not. So since 0 is in this interval, we are not confident that tribulus has an effect. Because remember, if 0 is within the interval, or any number within the interval, is a plausible value. And because 0 is in this interval, it's plausible that the difference is negligible or could be 0.